Okay, factor the expression. You're just putting that into as many parentheses as you can. Now, you're not solving the equation. You're not going to put x equals because there's no equals. You can't solve it if it's not an equation. Okay, so you just need to factor the expression. Okay, so first off, you'll need your multiplication table, and you also need your factoring properties sheet that I have provided for you. Okay, there's either going to be 2 terms or 3 terms in this. So 6x to the second power minus 60x, this has 2 terms. Okay, so in 2 terms, we first draw our GCF box and we see if we have a difference of perfect squares. Okay, so that you can abbreviate that with DOPS. Okay, so first we need to see if we have a greatest common factor. Okay, and then we need to see if we have a difference of perfect squares. Okay, so do you have x in the last slot? Yes, you do. Do you have a negative in the front slot? No, you don't. 6 and 60. 6 and 60 are both in the 6th row, so the greatest common factor that can be divided out is 6. Okay, so I put that in parentheses. Now, whatever we have in there, 6x, we need to put up below the lines and we need to divide. So we divide the 6 by 6, which is 1, then we divide the x to the second by the x, which that's how you divide x second by x. We have an x remaining. This wipes out, but there's still an x we would put alongside the 1. Then we take negative 60 divided by 6. Negative 60 divided by 6, and that's going to be negative 10. And x divided by x, okay, cancels out. Okay, now we bring the GCF over, the 6x. Then we need to cross this out and that out. So I'm just looking at the 1x minus 10. Okay. Now, first question is the second number, the second term right here, is that a negative? Well, yeah, it's got a minus in front of it, which would be plus negative. I'm not going to make it plus negative, but yeah, it's negative. Okay, so that has to be a negative. Okay, now are these perfect squares? Again, so you know that number right there is negative. Well, 1 is 1 times 1, so that's a perfect square. But the x, okay, is not to the second power. Okay, so that is not a perfect square. 1x is not a perfect square. 1 is, it's 1 times 1. But x without a power, it's not to the second power. So that can't be a perfect square. So you cross that out, you write no. And so you're just going to put that 1x minus 10 right after your 6x. Okay, next problem. We have x to the second power plus 14x plus 24. Now how many terms do we have? It looks like we have 3. Okay. So 3 terms would be GCF, and I'd set up my table to try to find the 2 factors that add to the middle. Okay. So GCF, then the T table. So I do not have x on the end. I don't have the negative in front. 1, 14, 24 would just be in row 1, so we would not do that then. Okay. Okay, so 1 times 24 is 24. Okay, and that is positive 24. And that means it's going to be a match. So, and we have to find 2 factors of positive 24 that add to positive 14. So 24 divided by 1 is 24. Okay, add those, you don't get 14. Now you take 24 and divide it by 2. You got 12, so you put 2 with 12. Now if I add those, That's negative 14. So I can stop dividing. I just need to make these so they're positive 14, which you do by changing both the signs to the opposite value. Okay. Okay, now I make my parentheses then. And you put in your positive 2, positive 12. Those are the two mystery numbers that we've figured out. Now you need to put what your A is. It's A is the x second, whatever. Here's my A, x second, that would be a 1. Okay, so the x second, we go into x times x mode. Okay, so x, because x second is x times itself. Now, whatever number's here, 1, that's what we apply in front of the x's, the coefficient there. If that was a 4, I'd be putting a 4 in front of the x's. If it was a 5, I'd be putting a 5 in front of the x's. Okay, so 1x plus 2, here's a 1, here's a 2, so that would be divided by 1. So it would be 1x plus 2. 1 and 12 would also be divided by 1. Now, these are the parentheses are right because the ABC trinomial has now turned in to 1x plus 2 times 1x plus 12. Okay, next problem. 49x to the second power minus 16. Okay, so now we're back to two terms. So GCF and then difference of perfect squares. Okay, so there's not an x in the final slot. Okay, there's not a negative in the front slot, so no x, no negative. Now 16 and 49. Okay. So 16 and 4 or 16, no 49. Okay. There's 16, no 49. Okay. There's 16, no 49. Okay. 16, there's no 49, so that leaves you to 1. Okay, so if it's 1, we ain't doing it. Okay, so we will not be doing the GCF. Now, remember how to do difference of perfect squares. Okay, you're going to draw arrows from this. Okay, and you're going to see if this is a difference of perfect squares. Now, first off, is the second term negative? Yes, it is. Okay, absolutely. Now, is 49 a perfect square? Remember, difference of perfect squares is where you look down the diagonal row, and 49's here. That's 7 times 7. Now, the x that's connected to the 49 is to the second power, okay? So that is a perfect square too, because x to the second is x times x. So we attach x on each of the 7's. Now, after that, the second term, 16, that's 4, 4. So you bet that is difference of perfect squares. Got the right sign on the second one. These are perfect squares. 7x, 7x, and then 4 and 4. Remember, the x's go in front of the signs, and then the constants go behind them. So 7x plus 4 times 7x minus 4. Okay, 20x to the second power plus 7x minus 3. So now we have 3 terms. So that would be GCF table. Okay, so I do not have x in the last slot. I don't have a negative in the first slot. 27, and 3. So 3 is the smallest. Yeah, I'm not seeing a 3 there. Okay. It'd be in row 1. Okay. Okay, so A, B, C. So you take positive 20 times negative 3. That's negative 60. So that's a negative, okay, so that's going to be a mismatch. Positive times negative. And you are adding to try to get to positive 7. So 60 divided by 1 is 60. 1 plus negative 60 is negative 59. Way off. 60 divided by the number 2 is 30. Okay, so 60 divided by 2 equals 30. Add 2 and negative 30, that's negative 28. That's way off. 60 divided by 3 is 20. 3 plus negative 20 is negative 17. That's off. 60 divided by 4 equals 15. That's off. 60 divided by 5 is 12. Okay. 5 plus negative 12, as you'll see on the calculator here, is negative 7. So we can stop dividing. We just need to change the signs, both of them, to the opposite value. So they still need to mismatch. They'll just be the positive here, the negative here. You can see now negative 5 plus 12 is 7. Okay, we found the two mystery numbers. Now put in your parentheses. We're going to go A equals, because later I'll put in the two mystery numbers that we found. Okay, now A, it's not what you're adding to. It's where you have your ABC trinomial. Your A is 20x to the second power. Okay, so this x second we're going to write as x times x. Okay, and then we put that 20 in front of each of the x's. Okay, so 20 and 5, so here's 5, here's 20, so that would be divided by 5. So that would be 4x minus 1. 20 and 12, so I go find 12, there's no 20, okay, 12, no 20. 12 and 20 would be 4, so we divide that down by 4. So 20x divided by 4 is 5x, and then 12 divided by 4 is 3. Now these 5s we're putting under here and the 4s, you delete those from the whole problem. Okay. All right, so let's line those up. So that means this ABC has turned into this. Remember, the numbers we end up with in front of the x's, 4 and 5, should times to what's in front of the x second, 20. 4 times 5 is indeed 20. 4x minus 1 times 5x plus 3. Okay, 4x to the second minus 9. Okay, so that's two terms, so that would be GCF and difference of perfect squares. So is there an x on the final term? No, there's not. Is there a negative in the front slot? No, there's not. So no x, no negative. 4 and 9. So 4 and 9, nope. 4 and 9, nope. It'd be 1, so we don't do it. All right, so then we take this expression, since we're not doing anything here, and we see if that represents a difference of perfect squares. Well, the second term has to be negative value. It is, okay? Remember, minus is like a plus negative. So that's the difference, okay? All right, now it's for a perfect square. Now remember, you're down the diagonal row. There's 4, be 2 and times 2. And then attached to the 4 is x to the second power. Well, x to the second power is x times x. So we put an x attached to each 2. 2x times 2x would be, because 2 times 2 is 4, x times x would be x to the second. 9 is 3 times 3. Okay, so 2x, 2x, 3, 3. So this turns into this. Oh no, what am I writing? These two things, sorry. 2x plus 3 and 2x minus 3. Okay, x to the second power minus 2x minus 63. Okay, that's 3 terms, so it'd be GCF table. Okay, so I don't see x on the final term. I don't see a negative in the front term. Okay, 1, 2, and 63. Well, 1's only in the one row, so GCF 1. So we take A times C, positive 1 times negative 63. Well, that's negative 63. So that's a mismatch. And the mismatch, when we add the factors, have to add to the negative 2. So 63 divided by 1, 63. 1 plus negative 63 is negative 62, so that's not even close. 63 divided by 2, decimal. 63 divided by 3 is 21, so 321. Negative 18, no. Decimal. 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 Okay, 7 and 9. So I'm going to take 7 plus negative 9, and that is negative 2. Okay. So the mystery numbers have been found. Now, before you fill this in, you should write A equals 1x to the second. So x to the second, we know that that's x times itself. Okay. Now you just apply the coefficient 1 in front of each of your x's, and then 1 and 7, so here's 1, here's 7, that's in 1's row. So that stays 1x plus 7. 1 and 9, 1 and 9 would be in 1's row, so that's 1x minus 9. Okay, so we replace this. The ABC trinomial is now replaced with these two parentheses, 1x plus 7 times 1x minus 9. Now check that. See if the numbers in front of the x is multiplied to what's in front of the a, the x second. Well, 1 times 1 is 1. And then these two without the x's, 7 times negative 9, should multiply to the c. If they do, you're right. If they don't, you're wrong. Okay, 5x to the second power minus 30x. Okay, now it's two terms. So two terms, GCF, and then difference of perfect squares. Okay, so I do have an x on the end, so we definitely need an x. We're going to factor out x. We don't have the negative in the front slot, so no negative. 5 and 30. So here's 5, here's 30. That'd be in row 5. So that's your GCF. Now you need to not just divide by 5, you need to divide by 5x. So 5 divided by 5 is 1. Then I divide the x second by the x. That would be x. Then we have negative 30 divided by 5, that's negative 6. And then x divided by x, that's a complete wipeout, so don't put x there. If you do, it's wrong. Okay, so you bring your GCF over here. Then you cross it out. Before you move to the next step, you cross it out and cross out the original, so I only am seeing that. Okay, difference of perfect squares. Is the second term negative? Yes, it is. Okay. Now 1 is a perfect square because that's 1 times 1. But x is not a perfect square. Okay, x is not x times x. That's x to the second power. So you cannot write this as a difference of perfect squares. Okay, so you write no. So you're just going to put that parentheses over here, 1x minus 6. Okay, last problem. 8x to the second power minus 14x minus 15. So there's 3 terms. Okay. So I would be looking for the greatest common factor. And then my table. So there's no x on the end, there's no negative in the front. Now 8, 14, and 15. So in the row of 8, 14, and 15 are not multiples of 8. 8's a multiple of 4. 14 and 15 are not multiples of 4. Okay? 4 is a multiple of 2, and so is, or excuse me, 8's a multiple of 2, and so is 14, but 15's not. So they're only multiples of 1. Okay? So we do not do that then, if it's just a 1. So you take positive 8 times negative 15. Negative 120. Okay, so that's a mismatch. Positive, negative. It has to add to the b, which is negative 14. This might take a little bit. 120 divided by 1 is 120. Add those, that's negative 119. That's not close. 120 divided by 2 is 60. That's negative 58. 120 divided by 3 is 40. Add those, negative 37. 120 divided by 4 equals 30. 4 plus negative 30 is negative 26. 120 divided by 5 is 24. 5 plus negative 24 is negative 19. So no. 120 divided by 6 is 20. Just go down past that if you need to. 6 plus negative 20 is negative 14, so nice, we got it, okay? So we finally found those nasty mystery numbers. So we put in the positive 6, the negative 20, and then your A is 8, okay? So x second we write as x times itself, then we place an 8 in front of each of our x's. Okay, so 8 and 6. So 6 is a multiple of 6, but 8's not. 6 is also a multiple of 3, but 8 is not. 6 is a multiple of 2, and so is 8, so we would divide that by 2. So it'd be 4x plus 3. Now 8 and 20, well, is 20 a multiple? There's 8. 20 is not a multiple of 8. 8's a multiple of 4, so is 20, so I would go with 4. So it'd be 2x minus 5. So bring those over here. Now again, the numbers in front of the x's, when you times them, 4 times 2 should be what's in front of the x to the second, 8. 4 times 2 is 8. The numbers without the x's, 3 times negative 5, should multiply to the c, negative 15.